All right, this is AP, AB, and BC Calculus. We're doing Unit 8, Section 1, which is finding the average value of a function. So let's get to it. So the mean value theorem for integrals, or MVT for integrals, is that if f of x is continuous on the closed interval from a to b, the average value of f on that closed interval a to b is given by the integral from a to b of f of x dx times a 1 over b minus a. So another way to think about this, and we'll spend a little bit more time on this in a second, is that it's the integral over the width of the interval, right? So you definitely want to memorize this formula. The next slide will walk through why the logic of it makes sense. Please note that if you just say MVT, you're referring to the one with derivatives, like instant slope equals average slope. If you mean this one, you need to see the MVT for integrals. So that's sort of like saying if you live in the United States and you say the Civil War, you probably mean the American Civil War. It's just implied that that's the one you mean if you say the Civil War. So similarly, if you say the MVT, you're talking about the one for derivatives. You have to be more specific if you mean the other one for integrals. So let's talk about why this makes sense. So remember that in the very simplest of senses, f of x is a y value, meaning it's a height, and integral is an area, right? So if we were talking about a box, area would be width times height. Or if you wanted to solve for the height, you could write that area is area over, that height is area over width, or 1 over width times area. So let's look at what we're talking about here, okay? So this, right, this integral is an area, right? If I want the average value, the average height of this thing, essentially what we're saying, so whatever the average value is, I don't know, I'm going to call it there. So let's call this the average f of x, right? That's the average value. What we're saying is if we created a box here, we'd be looking at a box that has the same area. So this box, this red box, has the same area as that blue curvy shape, right? So what we're saying is that this average height times this b minus a, which is the width, would give me this area, right? So we're saying that the height, f of x, like the average f of x, right, is the area, which was this integral, divided by the width, which was how wide the box is, b minus a, right? That width is b minus a. That's all it is, right? So it's the area divided by the width, but the area is the integral and the width is the change in x values. That's why this formula is what it is. So we're saying that this blue area, right, again, this curvy blue area that I'm doing a terrible job of drawing, has the same area as the red area. The red area is a box. The blue area is a curvy, irregular shape, but they have the same area. All right, so let's go ahead and find the average value of a function. So this is a pretty common question you'll be asked to do. Sometimes it's with a calculator, sometimes without. So this one's one you could be expected to do on your own. So the average value is going to be 1 over b minus a, so that's a 4 minus a negative 1. The integral from negative 1 to 4 of 3x squared minus 4x dx. So you have to show that setup. That's going to be really important, right? Even if something goes wrong in the integration, you should make sure you have that setup. So when I do the antiderivatives, I get x cubed minus a 2x squared, and I'm going to be plugging in negative 1 and 4, right? So that's a 1/5. When I plug in 4, and again, the 1/5 could stay in front of either, like both of them individually, or you could just leave the 1/5 in front of the whole thing. When I plug in 4, I'm going to get a 64 minus a 32, right? And then when I plug in negative 1, I'm going to get negative 1 minus a 2, right? So I get that this is a 1/5. In here, I have a 64 minus 32, which is a 32, and then this seems to be plus a 3. So I think I get 35 over 5, which is 7. Now we can check and see if we're right on this, right? It's not a bad idea to check. So, so even if you're doing something non-calculator, you should get in the habit of checking. Now here, this is an easy enough function to type in that if I want, I could go ahead and just type it in. I don't have to call it y1. So what I want to do is I want a 1/5, so we'll do a 1/5. And then I want math 9, which is function integrate, right? The function I'm integrating is the 3x squared, so 3x squared minus the 4x, comma, with respect to x, from negative 1 to 4, right? And then double check you've entered everything right. So 1/5 is in front. I have my integral with a 3x squared minus 4x. X, -1. Yep, that looks good. Hit enter, and there's my 7, right? So it confirms that I'm right. It's not a bad idea to confirm that you're right. I guess I don't need to drag this over. It's the habit I have from class that I always put it in the notes, but you don't actually see the PDF of these notes after all anyway, so it's fine. All right, cool. So moving on. Go ahead and try a P1. Same thing. You should be able to do this one by hand. You're definitely welcome to check it on a calculator, and you really should. Pause me if you don't want me to do it. So the average value is going to be, here my interval is -2 to 0, so 1 over 0 minus a -2, the integral from -2 to 0 of 5 minus 2x dx, right? So that's going to be a 1/2. When I integrate, I get a 5x minus x squared, and I'm plugging in -2 and 0. So I'm going to get that this is a 1/2 in front of, when I plug in 0, I'm just going to get 0 minus 0, so that's nice. Minus, when I plug in -2, I'm going to get a -10 minus a 4, right? Double check that I'm right. Yep, okay. And so what's going to happen, and this is just complete coincidence, is I'm going to end up getting a 14 over 2, which is also a 7. I promise that the average values of functions are not always 7s. It just happened here that it was. So if I hit second enter, I can make my life a little bit easier. I'm going to go up and change the 1/5 to a 1/2, right? I'm going to change the function to a 5 minus a 2x. With respect to x, oh, sorry, there's an extra x there. With respect to x from -2 to 0. And again, coincidence, but we get a 7. All right, moving on. And we will see some where we have to use a calculator. So it's worth knowing that, how to do it in a calculator for when we have to. So find the average value of the function on the interval, show the sufficient work to communicate understanding. So my average value, and again, the first thing you want to do is just straight up put out this formula, right? So 1 over b minus a, the integral from a to b of the function, right? So I'm going to get that this is a 1/3. When I integrate, remember this is an x to the 1/2, right? So when I integrate, I'm going to up the power by 1, which would be 3/2, and divide by that power. So it's going to end up being a 2/3 x to the 3/2, and I'm evaluating from 1 to 4. So that's going to be a 1/3. If you want to yank the 2/3 out, you certainly could. So 2/3 times a 4 to the 3/2, which we'll deal with in a sec, minus a 2/3 times a 1 to the 3/2, which is at least pretty accessible because it's a 1 to a power, right? So 4 to the 3/2, in case you need a refresher, is the same as the square root of 4 to the 3rd, right? So that's going to be a 2 to the 3rd or an 8. So that's worth knowing. So we end up getting that this is a 1/3, and then in here I have 2/3 times 8 minus 2/3 times 1. So I have a 1/3, and then a 16/3 minus 2/3. So I should get a 14 over 9, right? So that should be my answer. Now we can check this on a calculator. So we'll go ahead and hit second enter because, again, we've already typed in the stuff, so why not make life a little bit easier? We get that this should be a 1/3. The function I'm integrating is the square root of x, so second root x, close the parenthesis, and then do some deleting. All right, and then we're going from 1 to 4. All right, so if we do math frac, that'll give me my 14 over 9. All right, so go ahead and give this one a try, right? You're doing the same thing. Oh, my bad. Didn't mean to do that. All right, so my average value is going to be 1 over 3 minus 1, the integral from 1 to 3 of this. I'm going to write it as a 2x the negative second because it's just going to make my life a little easier. When I up the power by 1, I get that it's an x the negative first, and then I'm going to divide by that -1, so I get a -2x the negative first. So I get that this is a 1/2, and then a -2x to the negative first, which I'm going to write as a -2 over x from 1 to 3. So that's going to be a 1/2, and then when I plug in 3, I get -2/3 minus a -2 over 1. So I get that this is 1/2 So this is a negative 2/3, and this is plus 6/3, right? Because it's a plus 2, which would be 6/3. So I think I get 1/2 times 4/3, which I'm pretty sure gives me 2/3. So let's go ahead and check that one, right? So if we go over here, we do second, enter. Oh, twice, because I need to get up there. Yep. It was a 2 in front, right? 1/2. And then this was a 2. And then it's up to you. You could either do it as a 2 divided by x squared, which is fine, or you could do it as a x to the negative 2, like a 2x to negative 2. It doesn't matter which one you pick. And we're going from 1 to 3. And there you have it. That's my 2/3. All right. All right, so E3 gets a little bit trickier. So now we have a piecewise function, right? So we're basically going to have to treat the integral for the two pieces separately. The first thing you should check is that in order to find the average value, these two pieces have to intersect, right? But they do, right? If you check at x equals 0, the limit as x approaches 0 from the left of this function would be 0 plus 1, which is 1. The limit as x approaches 0 from the right of this function would be cosine of 0, which is also 1. So this thing's continuous, and this can be something that happens in your head, but you should just double check that it's a continuous function. So now that we know it's continuous, essentially in order to find the average value, right, so the average value, it's going to be 1 over 1/2 minus a negative 2, which we'll deal with in a sec, times the integral from negative 2 to 1/2 of f of x dx. The tricky part of this is that this actually needs to be in two pieces because I have two completely different functions. So if we clean up this fraction right here, this is a 1 over 2.5, right? That's a 1 over 5/2, so that's a 2/5. And then this thing is going to split into two integrals, the integral from negative 2 to 0 of x plus 1 dx, plus the integral from 0 to 1/2 of cosine of pi x dx. Right, so it doesn't bother me if you want to put the 2/5 in front of the entire thing, or if you want to specifically put the 2/5 in front of each one. It doesn't matter. It's going to come out to the same in the end either way. So when I do the antiderivative for each of these, right, I'm going to get an x squared over 2 plus an x from negative 2 to 0, right? Plus, I'm going to get, now when I integrate cosine of pi x, if I were differentiating cosine of pi x, every time I differentiate, I would have to multiply by pi because of the chain rule. Because I'm integrating, I'm going to have to divide by pi when I integrate. And the other way to think about that is that you could use U-substitution for this. It is U-substitution, but it's sort of a really simple case that a lot of times we just do in our head. So I'm going to get 1 over pi times sine pi x. And that's what I'm going to plug in, right? So I'm going to get that this is a 2/5 in front of this entire ugly monstrosity. When I plug in 0, I'm going to get 0 plus 0, right? Minus, when I plug in negative 2, I'm going to get 4 over 2. Minus 2, so that's going to be 2 minus 2, which is also a 0. Plus, when I plug in the 1/2, I'm going to get a 1 over pi sine of pi over 2 minus a 1 over pi sine of 0, right? And so this one's a 0, and this guy right here is a 1. So what ends up happening is I get that this is a 2/5 times, if I'm not mistaken, this is a 0 minus another 0 plus I just get that this is a 1 over pi minus a 0. So I think I get 2 over 5 pi as my final answer, right? So when we go to check this in a calculator, right, so this is a little tricky to type in my calculator. Unfortunately, the best option to type it in my calculator is to just probably go ahead and type this, right? I still have to make the mental leap to recognize it's two different integrals. So I'm going to go ahead and type in 2/5, right? And then, oh, that's not a 5. And then in parentheses, I'm going to start my parentheses because I need both of those integrals to be multiplied by the 2/5. And I'm going to do math 9, right? The first function I want is an x plus 1, comma, with respect to x, from negative 2 to 0, right? Plus the second one I want, so math 9 again, right? And then this one was a cosine of pi x, so second pi x, right, close the cosine, comma, with respect to x, from 0 to 1/2 or 0.5, whichever one you prefer, close the parentheses, and then hit enter, right? And then I'm going to check and see if that's the same as a 2 divided by the quantity 5 pi, and we're going to hope it is. Hey, it's a win. So there we go. All right. Let's go ahead and do another problem like that one. All right, same idea. Again, you should do the mental check that this thing is continuous at 0, but you can see that by visual inspection, right? This would be 2 minus 0, which is 2. This would be 0 plus 2, which is also 2. So it's continuous. You don't have to necessarily write a bunch of work to show that. So knowing that it's continuous, right, so we can go ahead and erase that. Knowing that this function is continuous, I know that the average value should be 1 over 3 minus a negative 4, right? And then the integral from negative 4 to 3 of my function. Again, the trick here is that this, right here, this is going to be in 2 pieces because there are 2 pieces to the function, so I have to integrate them separately. So again, I have this 1/7 in front of this thing that I know is going to be 2 pieces. So my answer is I keep that 1/7 in front of everything, right? And then I'm going to have an integral from negative 4 to 0 of 2 minus x with respect to x, plus the integral from 0 to 3 of x squared plus 4x plus 2 with respect to x, right? And then I'm just going to have to do the antiderivative for both of those. So I have this 1/7 sitting out in front. All right, so this is going to be a 2x minus an x squared over 2, and I'm evaluating from negative 4 to 0, right? Plus, this one's going to be an x cubed over 3 plus a 2x squared plus a 2x evaluated from 0 to 3. So it's not super fun, but, you know, we'll survive. So I have this 1/7 out in front. When I plug in the zeros, thankfully they're gone. So 0 minus 0, yay, that's something. Minus, when I plug in the negative 4, I'm going to get a negative 8 minus an 8, right? Because this will be a negative 8, and then this would be minus a 16 over 2, which would also be an 8, right? Over here, when I plug in the 3, I'm going to get a 27 over 3, right? Plus a 2 times 9, which is an 18, plus a 6, minus a bunch of zeros. So that's nice at least, right? So I end up getting a 1/7. Inside my parentheses, this was a negative 16, but there's a minus in front, so it seems to be a positive 16. This was a 9 plus 18 plus 6, right? Which I'm pretty sure gives me a 33. So 16 plus 33, right? So I end up getting that this is a 49 over 7, or just a 7, which we'll see if that pans out. And if it does, that's our third average value to magically come out to be a 7. Seriously, I didn't do that on purpose. So let's go ahead and check it out. Now I'm going to be kind of lazy. I'm going to hit second enter twice, because I noticed that I could probably just edit that function I typed from the other window a little easier than I could retype everything. So I get a 1/7. Instead of my first function being an x plus 1, my first function is now a 2 minus x, right? Again, this is sort of the lazy version of doing it, but that's all right. And I'm integrating, instead of a negative 2 to 0, I'm doing from negative 4 to 0. And it really was fortunate for us here that one of the bounds was 0, because it made life a lot easier. For the second function, I'm going to have an x squared, right, minus, and now I'm going to need to start inserting stuff. So minus a 4, and then we'll go ahead and do second insert x. Oh, sorry, it wasn't a minus 4. Let me go back and fix it in a sec. Plus 2. Sorry, it wasn't a minus 4. It was plus 4. Plus 4x. Plus 4x plus 2. Cool, cool, cool. From 0 to 3, and then I can delete that 5. Okay, so let's double check that's right. We have a 1/7. We're integrating 2 minus x from negative 4 to 0. We're integrating x squared plus 4x plus 2 from 0 to 3, and we'll hit enter, and hey, look, it's a 7. So again, totally accidental that 3 of our average values have turned out to be a 7. I genuinely made these up off the top of my head, and it just naturally happened. All right, let's go ahead and try an E4. So what's harder about E4 is that this is going to be a U-sub problem. Like, you're going to have to work a little bit harder to integrate it. So I know that the average value, yet again, right, is the 1 over b minus a, that's the width, and then I'm integrating from 0 to 2 of this thing. What's tricky about this is that this is U-sub. So the setup itself isn't tricky. The mistake is that some of us aren't very good at U-sub. So the trick here, right, is that this is my u, right? So I'm going to actually do the work separately, and you don't have to do this. I'm going to do the work without bounds, and I'm going to clearly label that I'm doing the work without bounds so that there's no confusion that I think that the bounds are u's, because the bounds aren't u's. So if my u is 2x squared plus 1, my du is a 4x dx, meaning I'd get a du over 4x to replace my dx. that means that this integral of x root 2x squared plus 1 dx is actually going to be an x times a root u times a du over 4x, and you can see the x's will cancel, so I'm going to get that this is a 1/4 a root u du, right? So when I integrate this, I'm going to get that instead of being a u to the 1/2, it's going to be a u to the 3/2. So I'm going to get that it's 2/3 u to the 3/2, right? Which means that I'm going to get that this thing is, I can cancel a 2 from this, is a 1/6 u, so 2x squared plus 1 to the 3/2. Like, that's what I should be getting. So this is my work without bounds. I'm going to cheat and do that. And then I can just jump down here and go ahead and plug into my integral. So that means that my average value, if we skip down here, so my average value is going to be, there's that 1/2 in front, right? Because we saw that 1/2 in front. And then I'm going to have 1/6 2x squared plus 1 to the 3/2 evaluated from 0 to 2. We can go ahead and plug in and do that, right? So when I plug in, I'm going to have this, I would, if I were you, yank the 1/6 out. I'd make this a 1/12. I think it's going to make your life a lot easier because that 1/6 could be factored out of here. So I'm going to get that that's a 1/12. When I plug in the 2, right, I'm going to get 2 times 4, which is 8 plus 1, so that's going to be 8 plus 1 to the 3/2, right? Minus, when I plug in the 0, I'm going to get 1 to the 3/2. Notice that that's not a 0 this time because there's a 1 in there. So I'm going to get that this is a 1/12. So 9 to the 3/2, we already saw in a previous example, is something that we can deal with. So just as a reminder, if we separate the work here for a sec, 9 to the 3/2 is the same thing as the square root of 9 to the 3rd. That's a 3 to the 3rd. So I get that this is a 1/12 of a 27 minus 1. That's a 1/12 times a 26, or 26 over 12, which is an okay answer. You could also cancel a 2 and get that this is 13 over 6. Right, so let's go ahead and double check that answer really quickly. So I'm going to go ahead and do 0.5 because it was a half in front and I'm lazy. Math 9. Right, and then so I had an x square root of 2x squared plus 1, close the root, comma, with respect to x from 0 to 2. We'll hit enter, right, and then we can math frac it, and there's my 13 over 6. All right, so P4 is basically the same as E4. Go ahead and give it a try. Pause me if you want to do it without me. All right, so again, we want to find the average value of the function, right? So my average value is going to be 1 over that 4 minus 0, and then we want to integrate from 0 to 4 of my function. So this is definitely U sub. So this is that same trick, right? So this is a 1/4 the integral from 0 to 4 of x squared e to the x cubed dx, right? So so this is definitely U sub. I'm going to do my work off to the side without bounds, right? So if I go to do my work, I'm going to notice that my u is an x cubed, right? It's the function in the function. So if my u is an x cubed, my du is a 3x squared dx. So I'm going to end up with a du over a 3x squared equals dx. So this is the integral of a 1/3 e to the u du, which means I'm going to get 1/3 e to the u, or a 1/3 e to the x cubed. Now, some of you might have been able to just see that, and that's great. And if you can, rock on, congratulations. Nobody thinks it's cheating if you can do that in your head, but if you can't do that in your head, that's also totally okay. So I'm evaluating this from 0 to 4. I'm going to yank the 1/3 out and make this a 1/12. I think that makes my life a little easier. And then this is going to be an e to the 64 minus e to the 0, right? So my answer is, honestly, it's probably just a 1/12 e to the 64 minus 1, or you could put the whole thing over 12. It's up to you. It doesn't matter. Like, you could do e to the 64 minus 1 all over 12. Doesn't matter. If you're checking this in a calculator, right, if you're going to check this in a calculator, again, I could put this function as y1. It's not an awful function, so I'm just going to go ahead and do it as is. So I'm going to go ahead and make the 0.25. There we go. 0.2. There we go. Oh, hang on. It's super laggy, hence the reason we have all of these extra numbers. Let's see if we can get it to work. The calculator is very, very laggy right now. All right, so let's try again. 0.25, right? Math 9. And then I want an x squared e to the x cubed. I think it's going to catch up with me in a sec. We'll double check that that's right. Okay. Comma, with respect to x, from 0 to 4. And then we'll double check when it stops lagging. All right, and we get an answer. In theory, it's going to think about it for a minute. In its defense, this is a fairly complicated problem, so it's thinking. All right, once it's done, I'm still going to have to type in the e to the, it might run into an overflow issue, actually, looking at the number e to the 64. It might have an error overflow, which might be why it's taking so long. Hey, it didn't have an error, but it's massive. So if I want to check this, I can't math frac it because e is an irrational number. So to check it, I'm literally going to have to type in my answer, which is going to be an e to the 64, right? So minus a 1 divided by 12. We'll see if we get the same answer. There you go, same answer, ginormous answer, but same answer. All right, again, good idea to check it in the calculator. You really do need those calculator skills because, hey, here we are, there's a problem where the calculator is required. So on this one, the calculator is required. We're gonna find the average value of the function. We're gonna round or truncate our answer to thousands places. So the trick here is the AP is not gonna give you credit for calculator notation. So what the AP needs to see, right? The AP needs to see the same thing they've seen on every other problem. They need to see the a minus, like 1 over a minus b. So in this case, that'll be a 1 over 4, right? The integral of 8.05x cosine of 5e to the x with respect to x, and you're integrating from -1 to 3. That's what the AP needs to see, and then they need to see the answer. They don't care about anything else. They need this. They need this. That's it. But you can't use, they don't need to see you write F integrate. They need to see you actually do the math. So this is a 0.25. And if you want to make this a 1/4 at the front, you certainly could. I'm sorry, the calculator's so laggy. This is a fairly complicated function. It might be worth putting it in as your y1. Like it might, let's actually go to y1 for a sec. It might be worth us not having to type this every time. So, so I'm just going to type it here, and I'm going to do 8.05 x cosine 5 e to the x, close the e to the x, close the cosine. That should work. Okay, so now I'm going to do 0.25, right? Math 9, which is function integrate. Vars, I'm going to go over to y vars, function y1, because that's what I called that entire ugly mess, comma, with respect to x, comma, -1 to 3, all those nice commas, and hit enter. Sorry, I think I hit enter twice, so it might get mad at me. It's thinking. All right, so once I get that answer, I'm going to round or truncate to the thousandths place. It's going to take a minute because my calculator is both doing a lot of number crunching and is also super duper laggy right now. My computer is struggling with the intensity of these math videos, legit. All right, so we're going to get an answer. Whatever answer we get, we will go to the thousandths place, either rounding or truncating. Come on, calculator, you can do it. I believe in you. This video is longer just because we're waiting for the calculator. All right. Okay, so it's going to happen eventually. While we're waiting for that to happen, we're going to go set up the next one, right? So P5, same thing. And again, hopefully at some point this calculator gives us an answer. I don't know why it's the laggiest calculator that's ever calculated. Anyway, while we're waiting for it to give an answer, we're going to go ahead and set up P5. Now, if this did happen to you on an AP, like let's say your calculator like tragically lagged and you couldn't get an answer, you'd still get lots of the points for actually setting up the information, right? So my average value is going to be 1 over 4 minus 1, the integral of this ugly monstrosity. Now, interestingly enough, because they called it f of x, you could call it f of x. and that would be acceptable. Like in your integrand, you could call it f of x. So this is the information you need, right? And then you're going to type and get the approximate value. I can't believe we're still waiting on the approximate value for the last one. Let's see. We might have to shut down the calculator, and let's see if we can quit out of this. It might be completely frozen. Calculator is suffering. All right, so we'd get an answer, but we don't have an answer right now. Let's see if we can quit the calculator, see if that'll solve some of this problem. Not sure if it's going to do it. All right, so let's try launching the calculator again. We might have to retype the stuff in. I apologize for the delay. Again, you can skip large chunks of this video while we wait for the calculator to function. Okay, so we have both of those set up, right? So here's what we're going to do. We're actually going to keep moving because the calculator is taking forever, and it seems sensible for us to keep moving until we have a calculator that functions. So okay, let's see if it works now. Oh, hey, there we go. Did it now. Okay, so let's go back. That's good, at least, that we finally got an answer there. We'll go back to here, right? Okay, so here's my answer to this first one, right? I'm going to get that this is a 0.697, and that's it. That's my answer. We go to the second one. The nice thing about this is because I already used y1 here, I can just go to my y1, and I can just change what y1 is. So I'm going to change it to be this. I'm going to change it to be the square root of 5.762 x to the third. E to the x, e to the 4x, so second e to the 4x, right, plus 7, and then I close the root. All right, so, and then if I quit out of here, right, I'm going to hit second enter, right, and then all I have to do is change the number in front. So this would be a 1/3. Unfortunately, you shouldn't use 0.33 for a third because that's not accurate. So you can, for terminating decimals, like you can use 0.25 for 1/4, but you cannot use 0.33 for a third because that's not accurate. So I changed that to a 1/3, and I'm integrating from 1 to 4. Right, and then we're going to go ahead and hit enter, and we'll get an answer. So we get that that's a 7871.335, and there's no other option because rounding and truncating would give me the same. Sorry for the calculator delay. So again, those are the two things you need. All right, let's talk about average velocity a little bit. So recall that when we did particle motion, right, we talked a lot about average. We talked about the relationships between velocity and position and acceleration and everything. So recall that old school, like third grade velocity, was just the change in position over the change in time. So if x of t is position and we want the average velocity from A to B, we would just write x of b, meaning the final position, minus x of a, the starting position, over b minus a. But we also just learned a formula for the average value of any function, which would also include v of t, right? So how is it possible that this average value, which is 1 over b minus a times the integral from a to b of the function, how are they the same thing, the thing in yellow and the thing in green? So the reason that it's possible to have these two different things is because they're actually not different. They're the same exact formula. So let's walk through. Recall that v of t is x prime of t. So if we were to integrate 1 over b minus a and we integrate v of t from a to b, that would be a 1 over b minus a times the integral from a to b of x prime of t dt. Well, based on that fundamental theorem of calculus, right, that's going to be 1 over b minus a times, when you integrate x prime, you get x, and when you integrate, so x of b and then minus x of a. Well, if you clean that up, that lands us at the same yellow formula that I started with. So they're the same formula. Which one of them you would use depends on the information you're given in a particular problem. So if you have an equation for x of t, right, then you'd use the yellow because you're like, hey, I already know what x of t is. I know it's x of 5 minus x of 3 over 5 minus 3. Great. If you don't have an equation for x of t, then you're probably going to use the integral of v of t, which would be the green one because you don't have x of t, but they get you to the same place. So let's go ahead and do a couple quick examples. We're not going to do velocity. It's just more examples of average value, but I just wanted to throw that out there because I think this is one that tricks people a lot. So let's do some tricky wording. The average value of f of x from -1 to 1 is 30. Evaluate this integral. Okay, so let's translate this statement into what we know it means. Okay, so what this means is 1 over 1 minus a -1 times the integral from -1 to 1 of f of x dx is a 30, right? So I'm pretty sure what that's saying is 1/2 the integral from -1 to 1 of f of x dx is a 30. So I think the integral from -1 to 1 of f of x dx is a 60, because I could multiply that 1/2 over, right? Well, if we look at this integral, this is the same integral as the integral. This is the same integral as the integral from, as I could yank the 1/5 out as a 1/5 times the integral from -1 to 1 of f of x dx. Well, this is 60, and that's this integral. So this is the same as a 1/5 times a 60, so this thing is a 12. All right, so the trick here is that I'm being asked to find an integral that I don't know anything about. I'm sorry that there's like this weird little blip on the screen. There's like a mark. It's not a prime, it's just that there's a mark. I don't know how that ended up there. But anyway, so let's try this again, right? So same idea, you're gonna try one without me if you want. So first thing we wanna do, the average value, oh, my bad, that's not the pen. The average value of g of x from 1 to 10 is 4. That's a statement that tells me information. It tells me that 1 over 10 minus 1 times the integral from 1 to 10 of g of x dx is apparently a 4. That says 1/9 times this integral is a 4, which tells me that this integral must be a 36, right? Because I can multiply the 9 over and say, oh, hey, this integral is a 36. So once I know that information, right, I'm now going to use that information, and I say, well, this is the same as a 1/18 times the integral from 1 to 10 of g of x dx. I can yank out that factor of 1/18. That's the same as a 1/18 times a 36. Oh, hey, this thing has a value of 2. So these are tricky questions, right? But it's using information that you know, right? So when you read this, it might seem really confusing. But if the first thing you say is, hey, wait a second, I know a formula for the average value. What is that formula? How does that give me information here? Well, then it's more doable. All right, let's do 2 more. Some values of the continuous function f of x are given below. Use the trapezoidal approximation with 4 intervals to approximate the average value of f of x. So we know that the average value of f of x on this window should be 1 over 8 minus 0 times the integral from 0 to 8 of f of x dx, right? That's what I'm looking for. I'm looking for 1/8 the integral from 0 to 8 of f of x dx, right? But then I'm told to use a trapezoidal approximation. So that's the definition of the average value, but now what I'm going to do is I'm going to say that the average value is approximately 1/8 times, and now I'm going to do a trapezoidal approximation from 0 to 8. So remember the way a trapezoidal approximation works, right? Is so this is the height of the box, right? Height is 2, height is 3, right? Because from 2 to 5 is 3. Height is 1, because 6 minus 5 is 1, and then height is 2, right? And then it's so the area of a trapezoid, right? The first trapezoid is going to be 1/2 the height, which was 2, times the sum of the bases, which would be the 10 plus 3, right? That's the first trapezoid. The second trapezoid is going to be, so this was my first trapezoid, right? That was the first one. This is the second one is from x equals 2 to 5, right? So 1/2 the height times the sum of the bases, which would be the 3 and the 2. Plus the next trapezoid would be from x is 5 to x is 6. So 1/2 the height times the sum of the bases. And I'm kind of out of room, but we'll make it happen. And then the last one is 1/2, the height is a 2, times the sum of the bases, which was 7 plus 1. Right? Notice that I started writing approximately as soon as I was doing an estimate. Like these were all equal signs, but when I got down here and started to approximate, now what I have is the approximately symbol. So I have a 1/8 in front. It's up to you. You could yank out the 1/2 if you want. I mean, it's not a bad idea. Like they all have this 1/2. So if you want to just yank out the 1/2, you could do 1/8 times 1/2, and that might make your life a little easier. And then you can clean this up, right? This is a 2 times a 13, which is a 26, right? This is a 3 times a 5, which is a 15. This is a 1 times a 9, it's just a 9. And this is a 2 times an 8, so it's a 16, right? So I'm going to have this 1/16 out in front, right? On the inside, I'm going to go ahead and notice that these guys together are 31, plus 9 is a 40. So these guys are a 40, which means I get 66. So I'm going to get that this is 66 over 16, which is a totally okay answer. If you want to divide by 2, it's a 33 over 8, right? So that's my value. Now, notice if you were doing this on an AP, it would probably be a free response question, and you'd probably be getting 2 to 3 points. One of the points would probably be for the trapezoidal approximation, so like for the work for it. One of the points would probably be for the answer, meaning that they understand that you could set up the trapezoidal approximation correctly and then do something dumb mathematically. The AP test knows that the very bright calc kids are often the same people that add 2 plus 2 and get 7. So you'd probably get a point for the trapezoidal setup. You'd probably get a point for the answer. You might be getting a point for units if it were a word problem that had units, but here it's not, okay? Let's try one last problem, same idea. Okay, so some values of the continuous function f of x are given below. We're going to use a left Riemann approximation, so not trapezoidal this time, with 5 intervals to estimate the approximate average value of the function from 0 to 12. So the first thing I should do is write what the average value of a function is supposed to be. It would be 1 over 12 minus 0 times the integral from 0 to 12 of this function, right? So I need to write that because that communicates understanding, and that's going to get me points on an AP, right? But then what I was told is that I'm supposed to take this and I'm supposed to use LRAM to approximate, okay? So I know that now I can put that approximately symbol. I have a 1/12 out in front. And then my LRAM is just making boxes. It's base times height, right? So let's see if I can squeeze everything in here. So the LRAM, so you have this width, right? So the width of 1, and you're going to use the left value as the height, right? And then you have the next one's going to have a width of 4, right? Because 6 minus 2 is 4. And then you're going to use the left y value as the height, right? And then we'll keep doing that. So the first box, right? The width of the first box is 1. The height of the first box is the left y value, which is 5, right? Then I'm going to do the width of the second box, which was from 2 to 6, so it's 4. And the height of the second box is the left y value, so that's 3, right? Then I'm going to do the width of this box, which is 2, right? Because 6 to 8 is 2. And then I need to times by the height of the box, which is going to be this 8, the left y value, right? So I'm never going to use the 9. That's sort of important information. That is the rightmost y value. This box has a width of 3, right? And a height of the left y value, which is 1, right? And then the last box has a width of 1 and a height of the left y value, which is 2, right? So this is slightly easier. I think the trapezoidal one's a little bit more work. So I get a 1/12, and then this is a 5 plus a 12 plus a 16 plus a 3 plus a 2, right? I noticed that these guys together give me a 10, and that these guys together give me a 28. So I'm pretty sure I get 38 over 12, right? And that's an okay answer. So you could say 38 over 12. If you want to cancel a 2, you certainly can, and you can make this 19 over 6, and that's fine. So again, you're probably getting points for the setup of the LRAM. You're not just getting points for the final answer, but you need to convey the understanding. You need to show that you understand what the average value formula is. You need to set up that you know what LRAM is, and then you need an answer. So this is probably a 3-point free response on the AP. And that's it for Unit 8, Section 1.